All right, welcome to HOFFTEC 101. Today we are going to learn about binary conversions. On previous videos, you can go to the channel. We looked at binary numbers in relation to decimal numbers, and we're going to go through the binary to octal, binary to hexadecimal, binary compared to binary coded decimal. What's the difference? But today we're going to focus on the basis of all, and that is decimal to binary coded decimal. So we're going to look at converting decimal to binary coded decimal and learn just how really easy that is. We could do this through scientific notation the way engineers do it, but we're technicians. I just need to know what that thumb wheel is supposed to read in my PLC so I can troubleshoot the thing. Let's get started. So I picked the number 791 decimal. Notice beside the least significant digit, which is the 1, I've got in parentheses a 10. In what we do for a living, it's important to denote the numeric system that we're in. And that could just as well be a hexadecimal number, because hexadecimal, if you remember, also uses 0 through 9. So I had to delineate this and say this is in fact a decimal number. If I look down below it, I see these binary positions of power. So each decimal number is the equivalent of 4 bits binary. So I am going to take and use 4 bits of binary code to represent each individual decimal number. And I'll show you. It is a very simple thing. So when I'm looking at this, I can see that the number 1, my least significant decimal number, it's got an arrow drawn to the first 4 digits of my binary coded decimal. The number 9 is my second set of 4 places, and my number 7, which is the 700th place, is represented again by 7 bits binary. I simply plug it in. So I've used the position of power again in the binary to identify the numbers. I simply add them up. So what I'm looking at when I look at the 7, for example, I've got to add up these numbers till they equal 7. 4 plus 2 plus 1 equals 7. So I turn each of those positions of power on, and 8 is 0. I don't need the 8. To make a 9, it's simply 8 plus 1. 8 plus 1, I turn off the 0, I turn off the 4, I turn off the 2, and I turn on the 1. 8 plus 1 equals 9. And that is my code in BCD. I look at the 1, I don't need the 8, I don't need the 4, I don't need the 2, and I need the 1. So then my binary number begins 1000, 1001, 1110, and that is the binary equivalent, the BCD equivalent of 791. So now when I look at this, the key to binary coded decimal is 4 bits of binary per every digit of decimal. Again, this is one video in a series. It's one video in a series of binary conversions for dummies. I hope you've enjoyed it. Check like, subscribe. You'll be my best friend. If you got any questions, drop me an email or drop me a message in the lines below. Thank you.